So I'm going to start by asking you a bunch of really weird questions, but I promise I'm getting to a point, right? So if we take a look at this meal here, I know you just had your pizza, so you're probably not feeling that hungry anymore. But if you take a look at this, try and guess, like, how many grams of carbohydrates do you think are in this meal? Like, not calories. I'm only interested in carbohydrates. Does anyone want to take a guess? Ooh. Go on. I think 140, 150 is probably about right. Those you'll see in a minute why those 800 guesses are pretty terrifying. Uh, so what about this one? Like, it's a drink, right? Do drinks have carbs in it? Any ideas how many carbs in a beer? 100, 25. There you go. Love it. But yeah, I think you're about right. And then the final one is a salad, right? Salads are healthy. Like, they have no carbs in them, right? But those little breaded, absolutely, the dressing, those little breaded pieces hidden in there, they all add up. So, there's going to be some carbohydrates in here too. So some of you are probably sat there saying this, like, who cares, right? Who cares how many carbohydrates are in it? People only care about protein, maybe calories if they're trying to lose some weight, maybe protein if they're trying to bulk up at the gym. But it turns out that there's a ton of people, including me, who really care about the answer to this question. There's about 30,000 of them in Ireland, well, 30,001 today. And there's around 8 million people globally. So in this talk, I'm going to talk to you about what I've learned from being on call for large incidents, and that how that plus quite a lot of Go has helped me to stay alive for the past few years. So in 2020, just as we're going through all the stuff with the pandemic, I was also diagnosed with type 1 diabetes. Chances are most of you have heard of diabetes, but you might not have heard of type 1. I had no idea what it was until I was diagnosed with it. So I'm going to give you a brief primer. So type 1 is an autoimmune condition. Usually when you're talking to people about diabetes, they're talking about type 2. Type 1 is effectively a condition where my body has killed my ability to produce insulin. I have no ability to produce it myself, and I have to inject artificial insulin every time I eat something. So whenever I see a meal like that, I have a ratio of how much insulin I need to have for how many carbohydrates are in it. And I'm doing mental calculations to try and roughly figure out how much I need to have. It's not caused by lifestyle. It doesn't have a cure. And in practice, that means I have to monitor my blood sugar at all times. If it's too high for too long, then it could lead to long-term damage and a shortened lifespan. If it's too low, even for a short period of time, it can be fatal. Sometimes if it gets too low, I'm paralyzed and I actually can't help myself. I can't eat or drink carbs safely, and I need support. This is really rare for me, thankfully. But every type 1 diabetic has their own story, and it's not so rare for some, unfortunately. So it's a condition you have to take very much seriously, and you have to respect, because if you take an eye off the ball, it could be fatal. With type 1, simple things can be quite taxing. So whenever I see food or drink like those I just showed you, I'm trying to work out what's in them and how to inject to counter that. And oh yeah, so just a small note, just for pedantry's sake, is I'm going to use the term blood glucose and blood sugar interchangeably throughout this talk. That they're roughly the same thing. So there's never been a better time in history to be a type 1 diabetic, I don't think. And I hope that every year goes by, I get to say that again, because things keep getting better. So even in the short time since I've been diagnosed in the past 4 years, technology's come a long way. And now I can monitor my blood sugar with this little tiny thing on my arm, rather than having to use this machine here, which you may have seen before, where people like prick the finger and they put a bit of blood on it and they put it in the machine and it gives a reading. I rarely have to do that anymore. So here's a picture of me wearing that fancy device. I am available for modeling work. I have to change this every 2 weeks. It's essentially a little tiny pin that goes in your arm on a circular disc. If you imagine a little tiny needle on the end of it, and it just basically pops into your skin. You've probably seen these about, like, they become really popular with, hilariously, people call them Gluke Bros, who like to track their blood sugar as they do gym work and stuff like that too.
You wear that all the time?
All the time. It doesn't come off, yeah. So what this does, it takes a reading like this. So my job is to try and keep it in this green box here. If it goes below the red line, that's when things are pretty fatal. If it goes above the orange line, it's probably time for me to do a brisk walk to try and get my blood sugar moving a bit. To take this reading, I have to tap my phone against the device. It uses like NFC to take the reading. But it gets kind of complicated. So being sick changes your insulin sensitivity. Going to the gym changes your insulin sensitivity. Losing weight changes your insulin sensitivity. So It's not just like, I know I need this many units, and then I do that every day, and then everything's fine. Like if you have a more active day, or if you're on a flight today, or any of these things, they all have impact. And so you're constantly just kind of recalibrating, if you will. But the most annoying thing is, because it's an IT system, is sometimes this happens. So when this pops up, I can't take my blood sugar anymore. And if my blood sugar was to reach dangerous levels in this 10-minute period where it's telling me to hang around, like I'm can't really think about it. This is where I have to go back to the needle prick, right? So in the first few months of diagnosis, I found this really stressful because I was really struggling to control my blood sugar. It was up and it was down, and I was really dependent on the monitor. And even today, I have periods where I'm going low, and I'm just like, I don't know why this is happening. I don't know what I've done to cause this. But in one of my more clear moments, I kind of thought about, well, if visibility was to drop like this at work, I would treat it as an incident, right? If I don't get any metrics, I can't see the system. If things aren't working, I would do something urgent. I would declare it an incident. So I wonder if I can apply that same thinking to the way I think about managing my blood sugar. So take a step back. I started this talk by mentioning that being on call and what I've learned about it has led to the system I'm about to describe. So I just want to talk a little bit about what it means to be on call, and specifically what it means to be on call at a company like Cloudflare. So all of you probably heard of Cloudflare. We take incidents really, really seriously, but we do have them, right? We do everything we can to stop them, but they're inevitable. This means that whenever we do see an issue, we aim to triage and fix it very, very quickly. And by doing this, we can typically stop smaller incidents becoming bigger incidents. If anyone in the company or an automated system detects that something is not working, then we raise an incident either manually or automatically. It's not quite a big red button, but like the concept's the same. We've developed internal bots that can be used to raise incidents. They manage the process, they generate reports. And we can ask it things like, like who's on call right now? Who should I go to for this specific issue? So if you are on call, this tech stack is probably this is like the de facto on-call tech stack, I would say. So at Cloudflare, we use this too. So to detect and raise incidents, we use all the familiar suspects. We use Prometheus, Grafana, Alert Manager, PagerDuty, as well as we have a lot of internal tools that do very specific things that we use. For those who are less familiar, Prometheus is an open source tool. It's used for event monitoring and alerting. It's really powerful, and it gives a great option for storing time series data, which is really powerful for seeing patterns over time, right? Grafana works really well with Prometheus and allows you to build dashboards on top of it to visualize that data. Alert Manager allows you to configure alerts for specific queries to trigger pages. So for example, if this data point moves to below this data point within a period of time, let one of our engineers know, because we don't expect that to happen. And PagerDuty, I hope none of you know what it is, but if it's on your phone, it gives you dread. It's the one that calls you out. It can override you do not disturb. It does all the things you don't want it to do. Apart from PagerDuty, all of these tools are written in Go, which speaks for the performance and the criticalness that Go can achieve. So if you're newer to the language, you should feel good that you've picked a strong language to learn. There's really nothing that it can't be used for, as far as I'm concerned. So every engineering manager at Cloudflare and some senior individual contributors receive training on what we call being an incident commander. It's not as glamorous as this at all. But some of the engineers I know do have setups that kind of mimic this. So as an incident commander, your job is, it's not just your job, you're empowered and you're encouraged to pull anyone in from anywhere in the company to resolve the incident as quickly as possible. And by resolve, I mean resolve customer impact, which means you must identify, triage, maybe put in a short-term fix. It might not be the overall global best solution, but just something to stem the bleeding. And then record long-term actions. So what we're going to do to make sure this never happens again. We do a review of every incident to ensure we learn from it, and then we go away and we do those actions to make sure that specific incident should never happen again and will never happen again. So at this point, you're thinking, why did Matt start talking about his blood sugar, and why we're talking about incident management now? Or maybe you're thinking, I know where we're going from here. So let me link you all together. So successful incident management is about collaboration. It's about working together towards a common goal, which is usually restoring established behavior, right? Typically, you have experts in particular areas, and you have escalation paths. In an ideal world, you engage as few people as possible to resolve an incident, as being paged is really disruptive, especially after hours. However, it's much less disruptive to fix a smaller incident than it is to ignore it and let it become a larger, bigger problem. So I wanted to apply that same thinking to managing my blood sugar. If something happens which causes my blood sugar to trend downwards, I want it to be notified so I can take an action before a major issue occurs. If for any reason I'm unable to self-resolve it, I wanted to feel good about the fact that someone else was going to get notified, like a family member, my brother, a parent, whoever's I'm on the best speaking terms with at the moment. Like they get notified so they can come and help me. So let's go back to this bit. I really wanted to get back to a place where I felt confident if my device was taking no readings or if I was critically low, I would be notified or someone else would. The device pictured, this little circle, is closed source. It does not give an easy way for you to build on top of it. It does not expose any APIs. It has no SDKs. So I spent some time trying to mess around with it to see if I could get some stuff off it, but I was really struggling. Which is after some research, I came across this clever device. So what this does, it slots over the top of the device and effectively scans the device every 2 seconds. And it sends the result to another app that is called Tomato. The really nice thing about this is even when the main device would show an error, this one was less concerned about the fact that it might be showing you anomalous data. It would just give you the data, which was great. So the main app's trying to protect you. It's seeing movement. It's saying like you don't want to see this. I'll tell you in 10 minutes when I've figured out the actual patterns. I wanted it anyway, so I wanted a way to kind of do something useful with the fact that this app would give me information the other one wouldn't. So the device had this really clever hack built into it that effectively publishes your blood sugar data to Google Calendar as an event every 5 minutes. And what this meant was you could put it on your Apple Watch because you could use the calendar complication as effectively a way to add a feature that the native app didn't support, which was like the Apple Watch. So I loved this. I love clever ways around like systems that don't want you to do something to make it possible. So absolutely. But I found this really exciting and it got my brain whirring as it meant that somehow they were publishing the data from there to the Google Calendar API, right? So there's some communication happening. So I just need to figure out how that worked. So while looking through the app, I saw this setting where it had this like data sync thing that they intended you to use with another system called Night Scout. But instead of entering a Night Scout URL here, I pointed at a web server that I was running. So I entered the URL and hit submit, and I saw these log lines in the gateway. So now I know what path it's sending stuff to. But I don't know what the data looks like, right? So to solve this, I wrote a really simple echo server in Go. So in this example here, I'm using something called encore.dev. If you haven't seen it, you should check it out. It's really cool. Like this whole thing is actually an app. Like that comment makes a HTTP handler. It's awesome. An echo server is, if you're not familiar with it, it's a server that just sends back the same request it receives. So in other words, whatever you send to it, it just echoes it back at you. This concept is simple, but it can really useful in networking when you're trying to figure out like weird application behavior or testing something. Echo servers are useful in any language, but they're exceptionally easy to write in Go. Like this one's barely 3 lines long and it's an entire echo server. And this is what I got back. I got some other requests and I started to see responses come back. And this one is exactly what I was looking for. So you can see like a date time. The SGV is like standard glucose variance or something like that, but it's a number I can work with. It's my blood sugar, right? And it also gives a trend direction, which is really useful. So this flat is basically saying you're stable right now. You're not going up, you're not going down. So I kind of have everything I need now to start building on top of it, right? So now we have an endpoint we can submit reading to. I made a gauge. So this is like a Prometheus thing where I can set my blood sugar every time I receive one. A gauge is a metric that represents a single numerical value that can only go up or down. It's used for measuring values that can fluctuate. So it's typically used for like memory usage, number of concurrent requests, temperature, or it turns out blood sugar. I also best efforts store my data, all my data in Postgres. This is probably the only use case I've ever come across where like writing to the database isn't that important. Like I don't mind. I'd rather it incremented the graph rather than up to the database. So I just thought it was interesting because usually you spend time obsessing about making sure the data is persisted. But in this case, it's just like if I store it, I can do something with it later, but I don't mind that much. So now I have my blood sugar being submitted to an endpoint every 2 minutes and setting a metric. So now I have a gauge being updated every couple of minutes. I can make a Grafana dashboard look something like this. It shows my blood sugar in real time. And as you can see, I can view trends over time. I could share it with people, and I can even set up a monitor at home with the dashboard on so I can see it in real time. So now I can share my blood sugar data with anyone. But this is kind of useless in isolation. If you remember, I said like it all matters in the context of what's just happened. If I've just eaten, it's really important that that's reflected, because if my blood sugar is going high, but I only ate 10 minutes ago, like that's not actually a problem. Like I don't care about that until like 2 hours into the future. So I kind of need a way to represent that on this dashboard. Otherwise, people aren't going to be able to use it to make decisions. And if you can't use it to make decisions, it's just a pretty graph, right?
If you're exhausted before you even get to your desk, then check out T-Cube co-working space. Located at O'Connell Bridge in Dublin city centre, means a maximum walk of just 3 minutes from over 100 Dublin bus routes, Dart Station, and both Red and Green Lewis. And after a long day of code crunching, getting home or meeting friends for dinner is also a breeze. We offer a low-cost, no-frills model, which means you're not paying for free stuff that you'll never use. T-Cube offers a range of flexible daytime and 24/7 options, meaning you can join our community of freelance and remote software developers from as low as €277 per month. And that includes VAT, coffee, and 1 gigabit Wi-Fi. So if you're looking for a distraction-free workspace, which you can come to and then get out again to enjoy your life in the comfort of knowing that you've been at your most productive, then get in touch today for a free trial. Call us on 675 9777 or find out more online at tcubedublin.com.
So I wanted a way to add context to this graph really, really quickly. I didn't want to have to log in and annotate it or anything like that. So Grafana supports annotations. It has an API for it. So I built a chatbot using Telegram that enabled me to add annotations very, very quickly just by typing them in. Telegram can be configured to send webhooks every time a bot receives a message. And so here's what that looks like. The webhook receives a request. I validate the message. I unmarshal it, and I write it back to Telegram to let me know if there was any issues processing it. After I've done the validation, I attempt to parse the ints and then call my annotation service before writing it back to Telegram and just returning OK to say everything's worked. My annotation service is really simple, and it assigns tags to the message based on its content and send these to Grafana, so I can say things like I walked, I ran, I ate, I injected. And then in Grafana, I can assign colors to these as a one-time activity to set up annotation queries, which culminates in the above. So I can make a message in my Telegram bot saying I just ate 50 carbs, and then you'll see like a line pop up here to represent that on the graph as to when it happened. So now we have visibility. We can see what's going on with my blood sugar and inside my body, but we have no alerts. It's still just a pretty graph. It's not doing anything to help me right now. So guidance given to me by nurses is that when my blood sugar goes below 4, I should start treating for it. And in this case, treating for it means consuming sugar effectively, like glucose. So I carry tablets with me all the time, or Lucozade is also a favorite of mine. So I wrote a tiny cron that checks my readings every 5 minutes. And if its reading is less than a predefined limit, it triggers incident. This is how you set up a cron in Encore. It takes about 2 seconds, super easy. And then I added this block of code to my Telegram bot to allow me to manually trigger an incident. So if for any reason I need to, I can just type it in this message and it will trigger the same process. So this is what that looks like. So what actually happens when I do this? So when I trigger an incident, it calls a little microservice I wrote, which opens an incident in another service called incident.io. So incident.io is, as you can probably guess by the name, it's a tool built for managing incidents at companies. But it also happens to be the closest thing to what Cloudflare has built internally that exists externally. And they were kind enough to give me access to be able to mess around and build what I wanted to build here. The reason I wanted to use an actual incident tool is it allows me to set up escalation policies. I can also run reports, which I'll show you later. And I can see how much time I'm spending like in the incident state, like how much time am I spending outside of the range I wanted to be in. I'll talk about this a bit more. I know some of you are probably gasping because I'm skipping errors here, but I promise you I only did this to make it fit onto one slide. One of the interesting sections of code I'd like to draw you to attention to here is the error block after making a HTTP call. So this is not something I've seen too much of, but it's super useful when you're building something new to just figure out what's going on and debug. So HTTP util package has two functions, dump request and dump response. I haven't seen them used much in the wild. You don't want to put these in production, but it's like super helpful while you're trying to figure things out. So let's go back to incident management. So we have the ability to create an incident, but the greatest value in doing so is that relevant parties are going to get notified. So we can do this just using the basic tooling of any incident tool, right? So this one lets me set up workflows. So this means I can configure something like this, which is similar to Zapier, I guess, if you've used that. So I can send notifications by text to folks who subscribed, and every time I open a workflow, it's going to send a text message to me as well. So I set this up. Every time an incident open, send me a text, and then on the left you can see what that looks like. If the incident isn't closed for 20 minutes, it will automatically escalate to the next person in the escalation policy. So if you think about it, like an incident opens, it texts me first and says, "Hey Matt, your blood sugar's running low. You should deal with it." This is nice because it means I don't have to keep checking all the time. Like it's push based. Like I'll get a text. I usually have my phone in my hand anyway, so it's really nice. But if I don't respond to that in 15, 20 minutes, it probably means I need help. And so it will automatically escalate to the next person on the policy, which would be my partner typically, unless she's fallen out with me. And one really nice thing about using incident tooling is I get reports for free. So this allows me to see what and how many incidents or low blood sugar events I've had over time. So I made this for demo purposes because my real graph thankfully isn't very interesting. But you can see that from this demo data, I could sit with my doctor and I could go through this and say, like, generally, the amount of incident low blood sugar events I'm having is going up, and we could have a conversation about my treatment plan, maybe changing some things, my diet, whatever it might be. So, being able to jump to your doctor and have like data-driven conversations is pretty fun. But what monitors the monitor, right? So it's getting a little bit meta now, but this is critical. You need to have things in place to make sure that if this doesn't work, something else happens. And this is really common to use at big companies or where having really high uptime is really important. You want to have something that some people call it like a dead man switch. It's like if your alerts aren't firing or incidents aren't happening, like something else happens, so you know that thing isn't happening. So how do you monitor a monitor system, right? So another nice thing about Encore specifically, but you can do this with most things, is it gives you a lot of insights for free. So you can see like requests, error rates. Like you may have heard of like RED. RED is a really great thing to monitor if you're not monitoring anything else. Requests, errors, duration. If you monitor those three things over your API, you're in a great spot and you're monitoring better than most people do. So here's an example situation that I was able to figure out with just these three metrics, right? My Telegram bot stopped working. It turned out it was getting a 404 from Grafana. So I guess they were having their own incident, and that's the thing when you're always using other people's tools is you lose control of some of these pieces. So this was really easy to debug because of this. Like I can just see straight away what the problem was, which is nice. So I've only shown you a subset of the features of what I've built or are planning to build today. But here's some other things like I'm either working on or already have. Right now I don't auto close incidents. So like after a period of time when my blood sugar returns to normal, like I just leave the incident open for now. I could auto close it, but I like to have the opportunity to review it and make sure I'm doing it, and it's forcing me to do that for now. But sometimes I forget to do it, which is why auto closing might be interesting. I mentioned I've been storing most of my data in a database. So I've been doing this for a couple of years now. So I have like quite a large database of my readings as well as context. So, AI is cool these days. I should do something with it. I could probably build some sort of model that I can chat to and figure out what's going on. But like seriously, I think this could be useful. Like for example, why do I always go low at 3 p.m.? And also this system's critical. So like as many fail safes as you can have is not enough, So kind of wrapping it all up, when I first got diagnosed with type 1, like honestly, I was pretty scared about it. It wasn't something I knew about. It sounds kind of scary. And there's lots of horror stories if you're going to read online about how it's debilitating and people can't do all the things they used to do. And while I won't pretend it's a breeze, like this project's helped me understand it. Like I had to go and read about how all this works, like how the numbers work, and to understand what good and bad looks like. And for me, that's a really powerful way to learn any topic, right? It's go and build a project around it. And this isn't a typical thing you build a side project around, but it helped me learn more than I ever expected it to be. And also, if you were working somewhere, maybe you don't get as much exposure to critical systems. Like here's a great way to figure out how distributed systems and failure work, right? being able to code, like to me at this point, it generally felt like a superpower. I've enabled myself to do stuff that I wasn't able to do with sort of, very expensive things that I could buy. As late as 1920, being type 1 was a death sentence. And so to be able to do this, 100 years on is awesome. The amount of amazing tool written in Go is great. Like I didn't particularly set out to use all the tools, open source tools that were written in Go. It just turned out that everything in this ecosystem is written in Go. Kubernetes itself is written in Go. We spent some time talking about that before, and it's amazing the power this language has and how widely adopted it's been within the community for really important stuff. So you should feel really good that you picked a good language. Go generally is low latency. It's got a great standard library, and it made me enable me to do this really quickly. I'm probably going to use other languages in the future. The LLM thing, Go's not really figured out its AI stuff yet, so Python's still going to dominate that for a little bit longer, but the Go team are working on it, so we'll see what they come back with. But I think Go's a great, sensible default, and that's kind of how we use it internally at Cloudflare. It's like, start with Go, and if it doesn't work, then use something else, but it really does fit nearly every use case we use. One thing that makes Go such a great standard is it's got a really strong backwards compatibility promise, which a lot of languages don't have. If you're running Go from 5, 6, 7 years ago, it will still work today. I actually have another bot that sends me a message every morning with what the weather is, and it's deployed on like an AWS Lambda somewhere. It was the first thing I ever built. I don't even know where it runs anymore, and it sent me a message every single day for the past 6, 7 years. It's amazing. So one final thing before I go is, if it doesn't work out as a software engineer, like I'm going to start minting NFTs of my blood sugar art. So here's my first one. If anyone would like to buy it. So thanks so much for listening. I'm Matt Boyle. You can find me in those places. You can probably spell Gophers right if you email me. I don't know what I did there, but.